Okay. All right. Can you see me? All right. Okay. Okay, thanks. Okay. Hi. I'm hoping I'm on the right place now, because before I was in the wrong sitting. So if you can't hear me, Jerem, if you could, or Professor Mohan, send me a message. Let me. So I'm assuming that you can hear me. Okay, so let me share my screen here. Okay, so so this this is the course handout for the finite element analysis design of electric machines, and so the idea here is that I will go over parts of the lecture in different sections, and then other parts are on the online video. I can't really present continuously for the whole day. So the course is split up into different sections. The first one is on the permanent magnet modeling, and so this is the course introduction here, and then I've provided, there should be links in the handout on Professor Mohan's website that indicates the different lectures. And so there's a link here with the Google link. There's also a link on the CUSP website. And so I've provided the links to the lectures that I recommend, and then so the idea is that you would go through these. They're about the time is shown here, so they're not completely 1 hour each. And then at 11 to 12, I will be back on, and I will spend an hour going over the first example, which is permanent magnet sizing example, because permanent magnet design is not taught in many classes, I think, and so I think this is quite good. So I'll use the theory that's talked about in the lectures, and then I'll spend an hour going over an example, and then so most of these examples that I will discuss, they have another component to them. So there's these handouts here. This link should be under the FEA for machine design link on the CUSP website. I've posted the handouts for the first 2 days. I need to add the third day. But for example, the handout 1 it has the BH curves for the magnet model that I will discuss in detail for the homework problem, the worked example, and then and so on. And then so. And then, so for example, this one is another example where I go over the fractional slot winding design, and I use these handouts to allow us to more easily explain the concepts. And so I'll write out the working using the DocuCam. And so the class. So then after this worked example, there'll be a lunch break, and then we're going to winding design, And then I will provide, there's a second handout, that's handout number 2, that will go over the electric machine winding function, turns function analysis, and then with some discussion on pitch factor and chord chording. And then the third discussion will be on the distribution factor for the machine, and that will be then related back to the winding and turns functions. And then day 2, day 2 will continue the sorry, it's going to be taking me a little bit of time to get used to this. Day 2 is going to go over the continue with the winding analysis, and we'll look at the also look at the fractional slot windings, which is quite an important topic, and concentrated windings. And so I'll go over a design example of a fractional slot winding using a handout and the star of slots technique. And then we'll look at magnetic circuit modeling of a rotary permanent magnet machine. And then on then day 3, go into theory and modeling using finite element analysis. And so I will, I think it's quite important to actually get a basis of understanding of math behind the finite element analysis program. Because that gives you an understanding of how it works and its limitations. And so in this, I go over some theory behind the mathematical modeling of using finite element analysis, and we talk about quasi-static and time varying. And I'll give an example. And then I'll talk about introduction to weighted residual method, which is one of the bases of finite element modeling. And then we'll look at Galerkin's method, which also is the basis of finite element analysis method, and then give some realistic examples using computer solutions. And then I'll provide you with a discussion on a finite element analysis project, and there's and on the CUSP website, there's a number of example problems. For example, the based on the fractional slot winding design, and you can design that and model that motor in the finite element analysis program. But you need to have the before you can design it, you need to have some theory behind the how the design works. So I spend time talking about the theory behind the machines, and then you can try out the finite element program to simulate the models. So at the end here in the handout, I actually provide 4 different finite element analysis software that can be supplied if you contact them. Especially if you're an educational institution, they're interested in giving you some of them will give you it for free. JMAG has become a popular one. They specialize only really in low frequency modeling. That the thermal analysis package is not for the machines is not it's not as rigorous as some, but the eddy current modeling is pretty good in this one. And then there's the Maxwell ANSYS. This one it has very good capability because it connects to the ANSYS mechanical, but that they usually don't provide this free. Mental graphics, which bought Infolytica. This is very popular. Magnet software is quite a popular one. It's got a very easy user interface, and it can model motion in multiple degrees of freedom. Which is kind of unique. And then MagSoft is a 4th one bought by Altair. They also couple that to fluid dynamic modeling programs. So this one is also quite good. So I have all 4 of these actually, and they all have pluses and minuses. And then there's also ComSol is another one, but it's not focused on machine design. Okay, so based on this handout here, the idea is to look at the lecture 8, part 1, and so I will log back in at 11 and go over a worked example problem on permanent magnet sizing for a magnetic actuator. Okay, thanks very much. I hope this worked, and I'll see you soon. So let me stop sharing here. So after, and by the way, I'll be, I'll be using the DocuCam, so I won't be using the screen. I'll be writing on using the DocuCam when we connect back. Okay, thanks. Bye-bye. How do I